What's up, everybody? It's Miss Wesley, and we are about to work on some practice with simplifying, adding, subtracting, and multiplying rational expressions. So a little bit more practice with 8-4 and 8-5. We're going to skip around this page, but together let's solve a few of these so that you'll have some left over to practice on your own afterwards. And we're going to start with number 1. So directions say simplify. I got to look at the top and the bottom, and just like you guys would always advise me to do, I'm going to see what factors. And I notice that the bottom is a difference of squares. So the disclaimer here is, you guys know Miss Wesley is left-handed. I have the bad habit of covering up a lot of my writing with my left hand. So I'm going to try my best to give you guys enough time to copy stuff down. But know that you can pause this, you can rewind, you can do whatever you need to be able to take good notes. Up top, I can't cancel a 2 minus x with an x minus 2. Those aren't exactly the same. No big deal. We usually just pull out a -1, kind of like a GCF, and you'll have negative x minus 2, making these two parts able to be canceled, with ones left over in their spots. So final answer is going to look like this: -1 over x plus 2. And then we've got the domain restrictions. We can tell from the answer we would never want x to be -2. That would make that denominator 0. But what's the other one that I'm not thinking of? Well, we crossed off an x minus 2. So let's put 2 on that list of other values x is not allowed to be, since it would make a previous version of the denominator 0. Okay, 1 down. Let's get into the more interesting ones. Let's look at 5, and it's been a few days since we've done this. This is the dividing question. I'd say first step is to leave the first fraction how it is. So I'm going to recopy 3x squared minus 2x plus 8, and then I'll recopy the bottom, 2x squared plus 3x minus 2. And we'd make this a multiplication question, right? We're flipping the second fraction. So this x squared minus 4 should come to the top, and the 3x plus 4 could come to the bottom. And this is where I really miss having you guys with me in class, because I know that you would be able to alert me of any mistakes you're going to see with the factoring, but I'll try to be real careful with the signs. Let's factor all 4 parts. So you've got this numerator trinomial, a 3x and an x, and then maybe we'd think like a 2 and a 4 of some sort. A 2 would go nice here and a 4 there. So you have products of 6x and 4x to be able to work with. We want a -2 in the middle. So let's go -6x plus 4x to make that happen. And then on the bottom, some similar factoring. You need 2x and x, and you need a 2 and a 1. So let's go 2, 1. We could always play around with those values, but how about something like that? On the other side, we've got that same difference of squares factoring that we saw in the previous question. So x plus 2, x minus 2, and then the 3x minus 4 that I really can't do much to right now. And what I call the fun part, anything you can see on the numerator of one fraction, denominator of another, doesn't matter where that is, we can cancel like factors with ones left over in their spots, right? And we've got, what else? X plus 2's canceling. And I believe everything else is going to be part of our final answer. So let's write it out. Up top, there's no need to FOIL through. We can leave the factored version, or since we've got 2 of these, we could write that succinctly as x minus 2 squared. And then on the bottom, 2x minus 1, 2x minus 1. That looks pretty good for a final version. Don't forget your domain restrictions. So I'll look in all these denominators. Well, clearly x can't be, let's see, what would make this 0? X can't be a half, right? And then I look at what I crossed off, right? I also know that x can't be -2, and we want x to not equal negative if we set this equal to 0, -4/3. And I'm wondering if that's it. I'm wondering if we caught all of them. Well, I got to be careful. Originally, this guy was on the bottom of a fraction. We need anything that would make that original denominator 0 also goes on the list of domain restrictions. So let's say x can't be plus or -2. And I think the only one I was missing on my list was +2. So lots of undefined values for x. Okay, we're going to try 2 more on this page. I like to look at an adding or subtracting question, and there are 2 good subtracting questions that I'm looking at, starting with 7. And this one is so good, it gets a star. And why does it get a star? Well, we haven't done this type of factoring in a while. I'd like to say I look in the denominator and see what factors first. And does a song possibly come to mind? This is a difference of cubes. So you can leave the first fraction as is. and we're subtracting 27. We've got, should I sing? Should I really sing? It's just me. Okay, sing it with me. Cube root, same sign. So you're going to cube root the first term, cube root the second part. So cube root the 27, and then same sign. We'll keep that negative. And then verse 2, square it. We're going to square that x. That's right here. Square it. This always goes on the other side. Square the -3. In the middle, best part of the song, multiply together and change the sign. So we'll go 3x with a plus in the middle. I'll just put a little music note there, since it's been a real long time since I think we've used that factoring in class. Well, why was that good? When you have an adding or subtracting question, we know this from a couple sections ago. You got to get a common denominator. And this fraction's good to go with those two parts in the bottom. It's this fraction that needs the trinomial. So this fraction gets an x squared plus 3x minus 9. And I should have said plus 9 there on top and bottom. X squared plus 3x plus 9. Okay. Now these fractions are ready to combine. So we're going to make this one big fraction. Let me switch colors here. You're going to have what we just wrote. So x squared plus 3x plus 9 minus 27 with those optional parentheses up top. You're going to see how we're going to get rid of them in a second. And then the bottom is the common denominator, x minus 3, x squared plus 3x plus 9. Okay. Up top, there's still more to do. We've got like terms. You've got x squared plus 3x. We don't need to say plus 9 minus 27 separately. We can call that minus 18. And then you have your denominator. And you'd think we'd be done. I mean, we're running out of space. We've done so much with this problem already. We've got a job to do, though. We've got to look in the top. We've got to look in the numerator of what we just wrote. See if this would factor any further to get one more thing to cancel. And I think we might get lucky. We've got, multiply to make -18. So x and x, factors of 18. One is positive, one is negative, and they've got to be 3 apart. So how about a 6 and a 3, with the bigger being positive? And lo and behold, we get one last little binomial to cancel. And those are the x minus 3s, with ones left over in their spot. So finally, we've got an answer of x plus 6 and then x squared plus 3x plus 9. Out of all the questions on this page, I thought this one was the most interesting and the trickiest, right? You got some tricky factoring in there. So I thought that would be a good one to try. In terms of domain restrictions, luckily, we don't have many. When you factor a difference of cubes, you're left in fully factored form where no real numbers would make that trinomial 0. I can't forget about x not being able to be 3. That's important. But other than that, I think that problem's good to go. And we're going to try one more on this page. The last one I wanted to look at was another subtraction question. And that'll be number 8 right here. So we can give that a try. Go ahead and factor. I know what you're thinking. I got to factor both of these denominators. So we'll make it 2 over x and x, 3 and 4, with the bigger one being negative. So we've got that factored. And let's see if we can get something similar on this fraction. You've got a 4 on the top, and then x plus 3 times itself, right? X plus 3 should be that factoring. Now we combine. So let's see. Give each fraction what it needs. Each fraction is missing a binomial on the top and the bottom. So it's missing an x plus 3 here, right? Top and bottom. And then x minus 4 here, top and bottom. I think if the setup is like so, you'd have both fractions over a nice common denominator. So now's the time to make that happen. Let's make this one big fraction all over all 3 parts, but I might write this the cool way. X plus 3, there's 2 of those, so we could say quantity squared, and then x minus 4, like that. We read across the top, and then we're going to try and simplify what we're going to write. So 2x plus 6, that's me distributing the 2 into those sets of parentheses. But here's why this one also gets a star. You are subtracting a binomial. That negative sign goes through to both parts. So you'll have minus 4x. That's not the part I'm concerned about. I'm concerned about the 16. The 16 needs to be positive. You're subtracting a negative value. So let's simplify up top. Let's see what we get. Negative 2x plus, is that going to be 22 up top? So we've got negative 2x plus 22. And then a denominator like we wrote it, x plus 3 squared x minus 4. Yes, I know the top does factor. You could GCF out a 2 or a negative 2. You know what? It's not going to make anything cancel here. So I'd say leave this one like that. Just don't forget your domain restrictions, right? X can never be anything that would make any denominator 0. So 4 or negative 3 would be good restrictions. On the back of this sheet, you're going to see some complex fractions. We're going to try one of these together. Remember that we have two methods for number 12 to be able to simplify. Method 1, I kind of like, would be get the bottom as one fraction. And look how nice that is because those have the same denominator. So it's going to be a 3 plus a 1 all over x. And then you bring it up and flip it, right? Dividing by a fraction is just like multiplying by its reciprocal. So 3 plus 1, we could just write 4 there, right? We're bringing the 4 down to the bottom. We're bringing that x up to the top. And you'll land with an answer like x squared over 4. Notice I didn't say to state the domain restrictions here. It's probably a good idea still to write or just to note that x can't be 0. But I wanted to also note that you have one other method. You could find a common denominator of the entire original. So up top and on the bottom, you could multiply by x. That's another method. So by method 2, you get to the answer a tiny bit quicker. You have an x squared up top. On the bottom, if you bring the x into both fractions, you just have 3 plus 1. This will give you the same exact solution. I hope this has been helpful. You're going to get some practice problems to try. And as always, let me know if you guys have any questions. I hope you're having a great day.